We've heard quite a bit this morning about serverless compute and about some of the wraparound that you can use in order to make applications that are built using serverless computing approaches more reliable, things like CI/CD and security. And as Matt said, for this next session, I want to look at something completely different, which is getting value from data using serverless approaches. So that's going to be the focus of this shortish 30-minute session. Just a little bit about me. I am leading developer technology evangelism at AWS. Before that, I got 20 years in technology operations and leadership. I like to take calculated risks. This is the top of the Blackcomb Glacier in Whistler, BC, after a heavy snowstorm. Those 4 people on the far side are the only people that have been on there before, so you could describe this as a calculated risk environment. Other things I do, motorcycles, CrossFit-style lifting, that sort of stuff. So in the context of my work, this means that I like to do live demos, another form of calculated risk, okay? And that's going to be a big theme for this next session, because I want you to participate in this session in order to help me illustrate what I'm talking about here. If nobody participates, this will be the worst conference talk you've ever seen, okay? So you need to do something in order to make this work out properly. Here's what I have for you in the session. So we're going to kick off by talking about the shape of the demo that I'm going to show to you. I'll talk about the architecture that underpins the demo, and hopefully you'll all interact with the demo during the course of the session in order to create a little bit of data for us, okay? We'll then talk a little bit about data ingest in the serverless environment using a service called Amazon Kinesis, which is a data ingest service capable of ingesting and maintaining sequencing for large volumes of data. We'll then talk a little bit about schema discovery. We've got a tool for evaluating data sets called AWS Glue that can build and project a schema onto data in various repositories. So we'll describe that a little bit. And then we'll also jump into some analytics use cases and some visualization using a couple of other AWS services. But everything is underpinned and hinges upon participation in this demo. And this demo is something that I've been using for quite a while to illustrate different aspects of AWS. The demo is an app, and the problem statement for the app is, do you like my talk? Okay, so the whole idea here is evangelists like me, other members of the team, we go out and do a lot of events. It's actually disproportionately hard to gather feedback from events like this, particularly with things like GDPR, where Matt is prohibited from giving me information about you unless you permit him to do so. And it's the same actually in most third-party events. So I was thinking about mechanisms for engaging with customers that come along to technical talks, that attend conferences, where they're not AWS first-party events. We don't run them, they're in contexts like this. So that's really what this demo is all about. Okay, so what you can do here is interact with an intelligent chatbot to provide feedback, okay? And there's several different ways in which you can do this. You can visit my Facebook page, okay? And you can like me, of course, on Facebook if you want to, give some of your personal data to Facebook. And by doing that, you can interact with the chatbot, a Facebook Messenger chatbot. If you don't want to do that, you can also visit bit.ly/ratingmytalk in your browser. And if you do that on a mobile or on a laptop or on a tablet, you'll enter into a chat session and you'll be able to have a dialogue with an artificially intelligent agent that can collect data about what you think about this talk. And I'll show you that a little bit later on, okay? So we'll actually encourage you to interact with it so we can gather a little bit of data to make this demo work, okay? Behind the scenes, a lot of things that Gillian was talking about in her session are, of course, present here. So we've got our Amazon Lex front end, we've got our intents, we've got our slots, we've got our natural language engine that enables us to dynamically construct dialogue in order to gather information from users. Behind that, we've got a Lambda function which validates the inputs that are provided and ultimately fulfills a couple of intents, one of leaving feedback, and another one of providing a rating, a score between 1 and 5, okay? Once we've got that feedback, we can do sentiment analysis on that, and we use another AWS service for that called Amazon Comprehend, which is a sentiment analysis service. And then we're using Kinesis to ingest those completed records, essentially, what talk, where, when, what kind of rating or feedback did you provide, ingest that, and using a Elasticsearch in the first instance to enable us to visualize and explore that data. So that's essentially what happens behind the scenes if you interact with this system. So I'd like to encourage you to try this. There's a couple of different ways you can do this. You can point your modern smartphone camera at this QR code. You should find that takes you to bit.ly/ratingmytalk. Or if you are still in love with Facebook, well, that's a diminishing set of people, but if you are still in love with Facebook, you can point, Facebook Messenger has its own proprietary QR-like capability. You can point a phone at your Facebook Messenger app on your phone at that circle, and you'll get the same thing, okay? And what happens if you do that? Is this. So if you use the web interface, you'll end up in a dialogue like this, and you can say things like, this reloads. This is the calculated risks part, okay, because the Wi-Fi in this building is, let's just say, a little bit flaky. So I can say things like help, oh, hello, and we'll get some help text back telling us how to interact with this intelligent chatbot. We can also do things like leave a rating. Too many people are hitting the endpoint. See what I mean about the risks? Okay, let's reload that. So you can enter into this dialogue. You should be able to enter into this dialogue where you leave a rating or provide feedback, and you'll get into a Q&A with the system. Okay. So you can say today, and then you can leave a score between 1 and 5 and ultimately conclude the transaction. Mostly works for users of the web interface. And ultimately what happens there is you end up submitting this package of data to our Kinesis service. Okay? So there's a code base behind here which validates the inputs that you provide and ultimately submits those records into this stream. Okay? And we can create these delivery streams using CloudFormation, of course, for infrastructure as code-based approach, or using the AWS console if we're working more of an experimental context, just trying to try something out or demo something. This is an example of actually a SAM template, which includes CloudFormation style syntax definitions to create one of these Kinesis stream resources. And you can see over here the monthly costs for something like that are around $11 per month. Okay? And that gives us a fixed amount of ingest capacity that we can use for submitting data into Kinesis, maintaining the ordering of those records, and ultimately get them persisted within another AWS service. One of the questions that I was asked last time I gave this talk was about auto-scaling for Kinesis. When we think about serverless services, we're normally thinking about services that are scaled directly in response to demand. Yeah, we don't want to be paying for capacity under this service model that is unused. And I guess you could argue that Kinesis doesn't necessarily fit that definition 100% because we always need one capacity unit, that's one chunk of throughput, to be provisioned in order to allow us to submit records into the API endpoint and have those records maintained in sequence. But in November last year, we posted this blog post, which is a solution for creating elastically auto-scaling Kinesis stream infrastructure. If that's something that you're interested in, I recommend taking a look at the post. It uses a new AWS feature called AWS Application Auto-Scaling, and then some custom Lambda functions itself to enable you to elastically scale a set of Kinesis shards, giving you variable throughput based on observed usage. Okay, so you can elastically scale these input streams. Once you have that, you can then send records to the stream, and you can send those records using a variety of different sources. We have a Kinesis client library, which is an open source Java library that is intended for really high throughput use cases, and you can embed that directly into your Java applications. We also have direct support for Kinesis in all of the different AWS SDKs that we have. Here you can see examples in Python, an example in Python where we are delimiting an existing JSON object, putting a new line on the end of it, and then we're sending that JSON object through a Kinesis client object using this put record method, and that's how we send data into our Kinesis stream. Once we have that, that data will be indexed and maintained within Elasticsearch with the configuration that I started with for my application, and we just end up with records that look like this. Record type, user ID, that's your Facebook user ID if you're using Facebook, location, date, the score that you've provided, and then the source ID for that particular record. And that'll end up indexed in Elasticsearch, as you can see here at the bottom right. So to do that, we need an Elasticsearch target cluster. And this is where I started realizing there was a problem with my application architecture, okay? And the problem is cost, okay? So I'm only periodically interrogating this data. I'm only periodically looking at this data. It's not a system that is in constant usage by anything like a significant population of users. I'm pretty much the only user, okay? And I'm certainly not hitting that Elasticsearch cluster anything like once a day. In fact, I'm rarely using it even once a week. But the maintenance costs for it are, well, pretty significant for an individual user like me. Here you can see that the cost to operate are $111 per month. I've got 2 nodes of a T2 medium cluster. That's the minimum required to maintain a durable system where we can tolerate node or availability zone failure, right? So my fixed costs for running that part of my application are actually relatively high, far outweighing any other component of the system in terms of cost. And I started thinking about, is it really worth $100 to be able to see a dashboard like this a month? That's $1,200 a year. And I quickly realized that that was actually a very expensive way to do it. So I started thinking about alternatives that I had for building the same functionality using different tools where I could eliminate those fixed costs and not have to run and maintain that Elasticsearch cluster, okay? And we announced something a year and a half ago or so, which was a really good answer to this problem. And when we did that, I implemented some changes to allow me to take advantage of it. So the first thing is storing my data directly within S3. So as well as my Elasticsearch target, which you can see here, I've got my Elasticsearch target there, I created this backup configuration which sends a secondary copy of the data in my Kinesis stream over into a nominated S3 bucket and prefix. Okay, so all of the records in my stream get bucketed up and sent to S3 in addition to being sent to Elasticsearch. You can see there's a couple of attributes down here that are relevant there. First is this interval in seconds, and the second is this size in megabytes. These are under an attribute type called buffering hints. And this allows me to control the frequency with which the contents of my Kinesis stream are dumped into my S3 bucket. I'm essentially saying whenever you hit a 60-second interval, a 1-minute interval, or you hit 50 megabytes of data in the stream, then write a copy of whatever you've got in the stream out into that S3 prefix. So that means that inside my S3 prefix, I end up with files containing all of the records that I've sent into my Kinesis stream. We end up with this sort of architecture where our data is going to 2 places. First of all, into Elasticsearch, and then a secondary copy into S3. And what I end up with then is a large number of objects inside S3 that are delivered on 1-minute intervals. Here you can see they're pretty small, so 129 bytes, 646 bytes, 2.4K. When that 1-minute interval hits, that data is getting purged out of Kinesis and delivered into my S3 bucket at those kinds of intervals. And if we look inside these files, you'll find that each one of these objects contains a file set of data containing records in the format that you saw a few minutes ago. So the record type, the user ID, the score, the location, the date, and the ID of the session. Okay, so that's what I end up with inside my, my S3 bucket. Of course, what I want to do is make use of that to build a dashboard similar to the dashboard that I had in Elasticsearch. Okay, so I need to project a schema onto these records and create an endpoint so that I can work with that data programmatically using data visualization tools. Okay, something like a Tableau or our own Amazon QuickSight, for example, replacing the functionality that you get inside Kibana, but doing so in a way which means I don't have to run those expensive Elasticsearch clusters. Okay? So for that, I have a few more tools that I can apply, and those are tools like Athena, QuickSight, and another tool called Glue. Athena is an interactive query service. It makes it possible for you to project a schema onto data stored within S3 and then query that data using industry standard SQL. Okay, what we do here in practice is provide a managed service based on Presto, which is a commonly used Hadoop ecosystem tool that enables us to manipulate flat file data and map that into relational data using a projected schema inside a DDL, a data description language. And that's exactly what I do here. Okay? With Athena, the pricing is based on scan volumes. So I pay a certain number of cents per terabyte of data that flows through that Presto cluster. Okay, now I don't have to operate the Presto cluster. We run a warm pool of capacity, and we provision that capacity in response to your query. We read the data out of S3 using those warm nodes that are now provisioned as Presto nodes, construct the schema, and return a response to your query. And we do all of that in an on-demand way. So you don't run a cluster, you don't run any nodes, you just hit our Athena endpoint, specify your query, we transparently spin up the compute capacity, interrogate the data set, scan the data set, build a set of query responses, and return them to you. Okay, and we do that in a few milliseconds for most queries. Obviously, for very large queries, it takes a little bit longer than that for us to do our scan. You get your responses back pretty promptly, and you don't have to operate any infrastructure for it. In order to do that, we obviously need to know what the schema of our data is. What are our tables? Okay, what are the fields within those tables? What are the data types that are present within those fields? Once we have that, we can write SQL against that endpoint, and we can get results back in return for that SQL. So the first thing I want to show you here is a little bit of another service called AWS Glue. And this is a data catalog service. It is itself serverless, and it has the concept of crawlers. These crawlers will do data discovery. I've got one already here that I've created, but I can very simply add a new crawler. And you'll see here that I have a variety of different data stores that I can use. I can use S3 as a data store. I can also discover data which is within JDBC compatible endpoints, so that includes all common relational databases. And I can also discover data that is within our own non-relational service, DynamoDB, which was mentioned earlier. For S3, I just provide a bucket path for the particular prefix where I want to find my data. So I'll grab that very quickly. You'll see this is a system-generated resource name, which is created by the Salmon CloudFormation template, which builds my infrastructure for this particular application. And my data actually resides in this prefix. So I'm going to copy this. Start that again, excuse me, sorry. Okay. The quirky Wi-Fi here, I think, might cause an issue with this because it's very high on the latency. But essentially what I can do there is specify an S3 bucket and prefix for my data, and then I can run this crawler operation. That normally takes a couple of minutes. And by doing that, I will discover the schema of the data which is stored within records inside that particular prefix and ultimately generate a table similar to the table that you can see here. If I jump into that, you can see that the crawler that I ran earlier today has correctly identified the contents of those JSON files inside that prefix. It's correctly identified data types for all of those attributes, so you can see that the data types are appropriately generated. And it also supports things like nested JSON within fields as well. So I've got a struct here that's been detected, and that struct contains the correct attributes that are defined within the nested JSON within that particular field as well. So it does have the ability to unpack JSON objects that are nested within your data set as well. Okay, so that's the glue discovery. Ultimately, what that creates, as I described, is a table for interrogation. As soon as that table's been created, I can then jump over onto the Athena console. I can see that table, and I can start to execute queries against that data set directly within Athena. And I can do that directly within the console. I'm not necessarily forced to use a visualization tool of the type that I'm going to show you in just a second. I can actually manually create SQL statements, query statements in SQL, and run those directly against that endpoint natively within the Athena console, which you can see right here when the Wi-Fi catches up. So if I run a query like select star from rating bot, you'll see that you can, right, I should disclose that I had to rebuild this system this morning just before I did this demo, which is why you're seeing these issues. So this table name has changed, so I'll just fix that. You can see there that I can run a query against that data set natively within the console and start to get results back from that query. So that table does exist, and I'm able to interrogate it using Athena. So what we did there, of course, was point glue data stored within our account, and that enabled us to discover a schema, stores that schema, and also stored associated metadata. There's another side of Glue that I'm not going to be covering in this session, which is an ETL capability that exists within the service. This is also serverless. What you can do with Glue from an ETL perspective is write and execute your own PySpark code. So into the same kind of model as the crawlers that you've seen there, you can schedule these jobs. So you can periodically run these distributed computing jobs to extract, transform, and load data from the different sources that are represented within your catalog. And that's obviously another capability that can be really helpful in dealing with data without having to run compute resources. So the last part of this, of course, is visualization and analytics. And for that, I'm using a service called QuickSight, which is our own analytics and visualization service. And you can see that service running here. So what I've got here is a visualization dashboard, which is pointing at the data source that I created earlier using Glue, and then pointing at that Athena table set to enable me to generate these visualizations. And this is a constructed dashboard which shows the same kind of data that was visual inside my Kibana-based dashboard that I was running earlier. That number's actually just increased from 309, I think it was, up to 324. And you can see that we've got 19 data records that have been input today in Cardiff. There was no data from Cardiff this morning, so at least 19 of you did interact with the demo successfully using those different channels. And what I can do here is build and add additional components to this visualization. You can do things like see the feedback. So broken, I give up. Awesome if you forget the live demo failure. Good, very useful to a current problem. So we can see that data's been entered via the chatbot interface, aggregated into those object files inside S3 and exposed directly through this interface. We can also do things here like filter down, so to focus only on records from Cardiff, for example, which we'll just try as a quick experiment. Let's apply that to all visuals here. So we got 15 scores, an average of 3.73, and in total we got 19 records, of course, we know that. These are the pieces of critical input that we got, and you can see the other components of the dashboard are building over time right now. So what I did there was replace that Elasticsearch cluster with that Athena-based backend, and I'm working directly to manipulate those records inside Amazon S3 rather than having to run any nodes inside my cluster. Of course, the reason for doing that was cost reduction, and the cost reduction effects of this change are kind of dramatic. Okay, so this is the last 12 months operating cost for my Elasticsearch cluster versus the last 12 months operating cost for the Athena-based version. Kind of interesting. So I went from $1,400 a year to run that down to 6 cents for essentially exactly the same functionality. So I think that's a pretty big win from a cost savings perspective, and pretty simple to do actually once you've got your schema mapped and you can start using some of those viz tools. Our ultimate architecture ends up looking like this. So I did actually leave the Elasticsearch cluster in place for illustration purposes. Of course, I don't pay my bill, so that's kind of easy for me to do. Goes up to some cost center in AWS, and it's useful to keep that running just to illustrate the relative run costs. But we get exactly the same functionality with this alternative approach, and I guess the most important benefit here really is we don't have to deal with any of the failure conditions that can be present within Elasticsearch. We don't have to deal with version upgrades. We don't have to deal with backing up our data. And we don't have to deal with some of the vagaries of Kibana as well, which I personally find kind of harder to configure than the other tool that I ended up using to build this system. Okay, so that's all I have in the session. I'm going to stick around after this and take a few questions. So if you do want to talk about anything that you've seen, please come and grab me. You can also ask my chatbot for the source code for this demo as well. So if you are interested in seeing how things are set up, just hit that endpoint and say, what is your GitHub? And you can get the details. Thank you.